Well, here we go with our first example. Find the Laplace transform of 1, a constant function 1. And it turns out that if we do our improper integral of 0 to infinity of e to the negative st times 1 dt, integrating with respect to t, it's just going to be, well, since it's an improper integral, limit as b goes to infinity of 0 to b. But what happens, the integral of e to the negative st is e to the negative st over s. Actually, negative e to the negative st over s. And b will be going to infinity, and we're going to integrate that from 0 to b. So when you put in b at infinity, that's e to the negative infinity, that's virtually 0 over s. But then when we put in the 0, we get minus negative 1 over s. See? We get minus negative 1 over s. We get minus from the negative sign in front of the function. And then this negative sign in front of the 1 over s, make it 1 over s. So we just learned the Laplace transform of 1 is 1 over s. And while we're at it, let's do another simple example. Find the Laplace transform of t. Well, that's 0 to infinity e to the negative st times t dt. That one you probably knew. So we integrate that by parts. You're going to see a lot of that in this lesson. U equals t, dv equals e to the negative st dt, so du equals dt, and v equals the integral we just did in the earlier problem, e to the negative st over s. So this integral is the integral from 0 to infinity of negative t e to the negative st over s. And when you put in infinity, this part makes it go to 0. And when you put in infinity, this part is infinity. Oh, really? That's a problem. It's infinity times 0. So what we really have is, let's do it the simple way. Let's make it infinity over infinity, t over e to the st. When you put it in infinity, of course, t over e to the st, one application of L'Hopital's rule, and you have 1 over e to the, actually, s e to the negative st, but the whole point is, you got 1 over infinity, so then you do get 0 when you put in infinity. But when you put in 0, what happens? When you put in 0, t is 0, so therefore you got 0. This whole thing was kind of wasted. It came out to be 0. But that doesn't mean we're done, because then we need to integrate this part. So integrating this, remember the formula for integration by parts, the negative is from this negative in the v, so plus, or minus a negative, so plus integral of v du. So that winds up being e to the negative st over s squared. Put in infinity, this is 0. Put in 0, this is e to the 0, which is 1. So you wind up with minus 0 minus 1 over s squared, so 1 over s squared. There we've done our second Laplace transform. What do you think the Laplace transform of e to the kt is?
I really don't know.
Well, I guess we'll look at that in the next example.